Welcome to The Explainer. Today, we're diving into a really cinematic, kind of gritty journey. We're exploring this massive alternate history question. What actually happens when ancient Rome harnesses the true power of steam? Throw out everything you know about the slow march of technology. We're looking at a world where water, fire, metal, and just sheer Roman ambition push the greatest empire of the ancient world straight into an early industrial age. Let's get right into it.
So what if a simple temple toy changed the fate of the Roman Empire? What's really cool about this premise is that it sets up a historically plausible alternate reality. We aren't dealing with time travelers, no futuristic magic, we're completely avoiding those fantasy tropes. Instead, we're looking at real, ancient knowledge and asking, well, what if the Romans just connected the dots differently? What if they actually recognized the raw potential sitting right in front of them?
In real history, Hero's Aeoliopile, which was the spinning, steam-driven metal sphere, was basically just a fascinating temple curiosity, a neat trick to show off at parties, right? But in our alternate timeline, Roman engineers connect the Aeoliopile to gears and pulleys. Imagine if these guys, who are already absolute masters of architecture and water power, hooked that spinning sphere up to their existing gear tech. Literally, a simple toy becomes the seed of a massive mechanical revolution.
Section 1. The Alexandrian Spark. From temple wonder to mechanical power.
Let's set the scene in the bustling, brilliant city of Alexandria. The Aeolipile actually existed in the 1st century CE. Hero of Alexandria wrote all about it. It used water heated over a fire to produce steam, and that steam shot out through 2 angled nozzles, making the whole sphere spin super fast. In our reality, the idea stopped there. But what if the Romans took these mechanics seriously?
Picture this. Roman officials in Alexandria, guys who are totally obsessed with efficiency and scale, witness the Aeolipile connected to simple gears and pulleys. A clever engineer takes that spinning axis and hooks it up to a basic gear set. The steam spins the ball turns the gear, and the gear lifts a heavy weight. Imagine the absolute shock on their faces when they realize that applying basic Roman engineering to this device changes everything. A fun little wonder transforms into a hardcore mechanical possibility.
Section 2. Engineering the Roman Machine. A gritty, early mechanical revolution.
Let's talk about how this actually works. Fire boils water in bronze pipes. Then, steam pressure turns gears. Finally, pulleys power cranes and mine pumps. These principles are simple but totally revolutionary. For a mine pump, fire boils water in thick bronze boilers, building up insane pressure. That steam turns a heavy-duty Aeolipile hooked up to interlocking gears. This continuous rotary motion drives an endless chain of buckets, pulling heavy water up and out of deep mine shafts continuously, without ever getting tired. And for cranes, those same gears multiply the torque, turning massive wooden drums to lift colossal stone blocks with just a fraction of the human effort. So we're looking at some incredible industrial applications of steam, like pumping water from deep mines, lifting massive stone blocks with cranes, powering large-scale stone workshops, and improving massive grain production. This wasn't magic, you guys. It was applied engineering used to massively scale up Rome's already crazy construction capabilities. Because of steam pumps running day and night, mines can suddenly go much deeper without flooding becoming a death sentence. Harbors are built way faster. Rome doesn't magically become the 21st century overnight, but it definitely kicks off a raw, gritty, early mechanical revolution.
Section 3. Fueling the legions. Logistics over lasers.
When we talk about military advantages, we're looking at faster, mechanized supply lines, steam-assisted siege engines, rapid bridge construction, and accelerated legionary fort building. Look, when people think of alternate history empires, they usually jump straight to steampunk lasers or giant mechs. But the true military advantage here? It's logistics. Wars are won on supply chains. We're talking mechanized carts moving heavy grain and armor, steam-assisted siege engines that wind back massive catapults in seconds instead of minutes.
The Roman army builds an unstoppable war machine by enhancing their traditional focus on construction, logistics, and supply systems. By relying on this gritty engineering, the war machine becomes terrifyingly efficient and entirely plausible. The Roman legions were already the greatest combat engineers in the world. Give them steam power to cut timber, move earth, and transport food, they become a force no ancient army could ever hope to outmaneuver.
Section 4. The cost of steam. Fire, metal, and ambition.
But progress always has a dark side. The stark reality of early steam power brings endless fuel consumption, dying forests, deadly boiler explosions and choking pollution. This new power is hungry. It takes massive amounts of wood and coal. The pristine forests of Italy and Gaul start vanishing rapidly just to feed these iron stomachs. Plus, ancient metallurgy wasn't exactly perfect. Pushing bronze and early iron boilers to their absolute limits leads to catastrophic, lethal explosions. On top of that, city skies become totally choked with soot.
The skies of Rome turn black with soot as our ambition burns faster than our forests. Imagine hearing that from a weary ancient engineer watching the environmental cost of the empire's unending ambition. The eternal city, literally coated in ash.
Section 5. Politics, Slaves, and Power. An empire shaken.
Let's look at the Roman factions and their political motivations. The Senate fears instability and wants to protect slave wealth. The emperor desires ultimate economic control. The army and generals demand more machines for rapid logistics. Engineers dream of unending mechanical progress. And workers and slaves see the possibility of a different future. This tech shift is an absolute political powder keg. The Senate's wealth is tied up in massive estates run by slave labor. If machines replace them, the Senate loses its power. But the emperor? He sees steam as a way to bypass the Senate and own the state's industry. The army is pounding their fists for more machines, the engineers are caught in the middle, and the tension is just completely explosive.
Rome's economy depends heavily on slave labor. If machines begin to replace human muscle, the entire social hierarchy will begin to shake. That's the core issue right there. Because the economy is built entirely on human backs, introducing tireless mechanical muscle threatens to completely upend the whole social order. Slaves and lower-class workers suddenly see a glimmer of a world where they don't have to break their backs in the mines. But the elites, they see that exact same vision as a terrifying threat. Section 6. The ultimate test. Can the empire survive progress? Could Rome control the power it discovered? We've seen the raw mechanics, the military expansion, the pollution, and this deep empire-shaking social upheaval. So I want to leave you with a final provocative thought. We know the Romans were absolute masters of discipline and conquest, but a mechanical revolution isn't just some barbarian tribe you can defeat with swords. It's a force that changes society from the inside out. Even with all their brilliant engineering, could the Roman Empire truly survive the unstoppable forces they unleashed? Or would the Roman machine ultimately tear itself apart from the inside? Thanks for hanging out with me for this explainer, and I'll catch you next time.